Hi, folks. Today's topic is functions part 2. So last time we dealt with functions. We kind of introduced what a function is, and for every x, there's exactly one y. We talked a little bit about function notation. Today we're going to talk about finding the domain of a function. So you're going to be successful if you can apply these. We got a couple of steps that we're going to look for here to help us figure out what the domain is. So I picked a piecewise function here. I wanted to point out this is when I evaluate a piecewise function, it depends on where my x value is in terms of which piece I plug it into. You know, kind of your instinct would be, well, I plug in, let's say that I wanted to figure out what f of 1, let's say I wanted to find f of 1. Well, it's kind of tempting to plug 1 into all three of these, but the problem is 1 doesn't fit with all three of these domains. And think about it this way. If I plugged 1 in for this, I would get 4. If I plugged 1 in for this, I would get 1. If I plugged 1 into this, I would get 3. That means that my one input would have 3 outputs, which means that I would violate the definition of a function. One x has multiple y's. So when we plug in a function value, we have to make sure that we're plugging it into the right piece of the domain. This function, this piece works for all x's that are less than -1. If I'm looking for an x value of 1, that's not going to be in this domain, in this partial domain, restricted domain. If I look for 1, yeah, 1 is between -1 and 2. -1 fits in there. So that's the piece that I would plug it into, and I would do 1 squared would be 1. Now, if I go down to my graph and I go to 1 and I track up, yeah, that fits. That fits with what we found. That x value of 1 has a y value height of 1 as well. Let's pick a different one. Let's pick 2. Let's pick 2. Let's pick 2. So let's say I want to find f of 2. This gets a little stickier because there are two pieces that have a domain that deals with 2, but only one of them includes 2. This is for all the x's that are greater than 2. So if I wanted to plug in 2, I couldn't plug it into this piece because 2 is not greater than 2. But if I put 2 in here, 2 is less than or equal to 2. 2 squared is 4. And if I look at my graph at 2, I trace up, that's at a height of 4. So that's good. That has a y value of 4. F of 1 equals 1. And I mean, you can get the idea. Plug in -2. If I put in -2, -2 fits into this category of being smaller than -1. So I would put -2 into this piece. F of -2 would give me an output of 1. That's legal. Remember, you can have lots and lots of the same outputs, but they have to all have different inputs. So -1 goes to 1, -2 goes to 1, -1 goes to 1, 1 goes to 1. There are 3 different x values that have the same output, but remember the definition of a function is for every x there's only one y. So this 1x only had one y, even if it's the same as this one. Now you might say, well, wait, doesn't this have 2? No, that's an open circle. So this point occurs at 1. There is no point at 2. It's a hole. So I can get as close as I want to that height of 2, but I'll never actually get there. All right, so let's try. I'm going to do this one with you, and then you're going to try to do these 6 on your own. So I gave you a function, and now you're going to use that function to evaluate some different function values. So g of -1. So this is my g function. Remember, the letter out front is just the name of the function. This is the f function. This is the g function. This is the h function. So g of -1 means I want to figure out where g has a domain of -1. Is that smaller than or equal to less than or equal to 0, or is that greater than 0? Well, -1 is clearly less than 0, so I'd plug it into this. -1 squared gets applied first. That makes it a 1 times 2 is 2 plus 3 is 5. All right, 0. This is one that's got to pay a little bit more attention because there's a 0 here and a 0 there. They both have 0, but only one of them includes 0, and that's this one. So 0 squared is 0 times 2 is 0 plus 3 is 3. And then g of 4. 4 is greater than 0, so I would plug 4 into this, and that would make it a -4 minus 1, which would make a -5. Okay, so hopefully you have the idea. Let's see if you can now evaluate h of x at these 6 values. All right, let's see how you did. So h of -4 is smaller than -2, so I'd plug -4 into this. That'd be -12 minus 4 is -16. -2, nope, that's less than -2, so I want to go to the one that's -2 included. So -2, that's 4, that's 10, that's 18. Take away 4 is 14. -1, no, -1 is between -2 and 2. So that would be -1, that'd be -1, that'd be 5, that'd be 13, that'd be 12. 0, 0 is between -2 and 2. So 0, 0, so that'd be 8. 2 is not included here, but is included there. So there's nothing to plug in. The answer is always -5. So for any x value that's greater than 2, you will have an output of -5. So same thing with 4. 4 fits into this domain. So that means that my output's going to be -5. So hopefully that makes sense on how to evaluate a piecewise function. The second half of today's notes are talking about finding the domain of a function. And there are 3 words that you should think of when you're trying to find out what the domain of a function is. You should look for problems. Look for problems. So the next logical question is, well, what's a problem, right? Well, let's talk. There's 3 problems. We're only going to talk about 2 of them. We'll talk about the third one when we get to unit 3. So here's the first problem. Number 1. X on bottom. That's my first problem. If I have an X on the bottom, I have a problem. And the problem is that you have an error. This is called the divide by 0 error. So if you have an X on the bottom, that X potentially could be worth 0. And so that would mean that we would have to divide by 0, which we don't like to do, which would be a problem. Our second error, our second problem, is when there's an X under a square root. The error here, I don't think I like the capitals. I wish I wouldn't have done capitals there. The error here is that we cannot square root a negative. So if you tried to square root -16, well, I could square root 16, I would get 4 or -4, right? Both of those, well, I would only get 4. I should be picky there. But I can't square root -16. There's no one number that when you multiply it by itself would equal -16. Now I'm going to be a little bit even more picky here because I want to point out that when I say under a square root, I really mean under an even root. So I say square root because 99% of the time it's going to be a square root in this class, but there really should be any sort of an even root. You've got a problem there. So when we have these problems, so when you have an X on the bottom, well, I'll wait till I get down to these examples to try to explain some of it. So before I go on, I want to talk about this stuff called interval notation because we're going to write all of our domains and ranges in interval notation. So flip over. This is what we call set notation. This is X is greater than or equal to -3. You can still write stuff in set notation, but any sort of advanced mathematics is usually done using interval notation. So there's a couple of notes that I want to talk about at the top. So let's start off by making 2 categories. So we want to call do include and then do not include. All right, so our current symbols for do include less than or equal to or greater than or equal to. We also have a filled in circle when we want to include something. It turns out to be a dot. And now we're going to have this new symbol, which is bracket. When you want to include it, you want to use a bracket. When we don't want to include, that's a situation where it's less than, or it's greater than, or it's an open circle. And this interval notation symbol is parenthesis. So when we don't want to include, we use a parenthesis. All right, let me give you some examples to show you what I'm talking about. Now, I like to introduce this using number lines. So eventually, we're not going to have to write these number lines every time, but I think it really helps initially to draw some number lines. So I'm going to do all my number lines in the same color. Now, this is a simple number line where we only have to indicate one value. You don't have to put 0 on there. I know some teachers make you put the 0 there. We're just trying to get an idea of what interval notation looks like. All right, so I want to highlight all the points that are greater than or equal to -3. So first of all, should I use -3? Yes, -3 is included, and we show that with a closed circle. And then I want to shade everything greater than. So this side is the greater than side. Now, because that goes up forever, I actually highlight the arrowhead as well. Now, to turn this into interval notation is always read left to right. So coming from the left, nothing, 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 boom, -3 is the first thing we use. Now, do we want to include it or do not include? Well, because it's a closed circle, we need to include it, so our symbol would be a bracket. Then you put a comma, and comma means until. So like this is going to go -3 until when? That's kind of how you want to think about it. So how far to the right do we go? Well, we go forever. Well, who lives up here? Who lives at the top? Now, we can't just say infinity because you got to be careful. This is positive infinity. So sometimes it's helpful to put the plus in front. I usually don't. But you have to put it, you have to be careful because there are two kinds of infinity. All right, let's look at the next one. Like I said, I'm going to do all of these with a number line for now, and then I'm going to get away from the number line on the other side. Okay, start with 3. Is 3 included or not included? Well, 3 is clearly included. Sorry, not included. 3 is less than x. So 3 is not included. Our symbol for not include is an open circle. Then I go to 5. 5 is included. That's our symbol is a closed circle. And now I want to pick all the x's that are smaller than 5. See how the x is on the less than side of 5, but x is on the greater than side of 3. So that means it's everything in between. So let's turn this into interval notation. You always read from left to right. So coming from the left, the first thing that we hit is 3. But that 3 needs to be not included. So our symbol for not include is a parenthesis. And then we go until 5. But we do want to include 5. So it's okay to have a parenthesis and a bracket in the same interval notation. Now, I didn't do a very good job on my bracket there. So you got to be real picky about drawing your bracket versus your parenthesis. I need to be able to clearly distinguish between the two. All right, x is not equal to 5. So the only thing I need to highlight is 5. Okay, it says that it's not equal to 5. That's the only information they told us is that it can't be 5. So I go to 5. Can I use it or not use it? No, it's literally the only thing we can't use. So I indicate that with an open circle. But if you can't be 5, but then you can be everything else. So that's going to be everything on this side, and that's going to be everything on this side. Okay, let's turn this into interval notation. So coming from the left, well, this goes down forever. It goes left forever. So who lives on this end? This would be -infinity. Now, when it comes to the infinities, I should have said that over here. You can never include the infinities. You can never actually get to infinity, so those are automatically not included. We go from -infinity until 5. Can we use 5? No, we can't. Now look, these other ones we could just stop because there's only really one section. This has two sections. This has the section before 5 and the section after 5. So we use this symbol, which means union. I know it kind of looks like a U, but it's not. It doesn't have the little tail of a U, but that means union. So we're going from negative infinity until 5. Don't use 5. That's what this is saying. Then the second half starts where? Well, what's the first number after 5? It's not 4. Or sorry, 6. It's not 6. It's not even 5.1. It's not even 5.01 or 5.000. You see the problem? So we have to say that we want to start at 5, but don't use 5. You can use any number after 5, but you can't use 5. And then we go all the way up until infinity. Okay, let's have you pause here. Try to do those next 3. All right, let's see how you did. I'm going to change the color of my number line. I only care about 2. I can't use 2. And I want everything that's less than 2. So now coming from the left, I would not include negative infinity until I get to 2, and then I would also not include 2. Negative 2 and 4. Negative 2, I'm going to use it. 4, I'm going to use it. I'm going to use everything in between. So coming from the left, negative 2 is included. 4 until 4, which is included. And then that's my whole interval. And then last, let's use a purple here. Okay, so this simply says that you cannot be 2 or negative 2. So negative 2 is out. 2 is out, but everything around those, everything between them, everything after them, everything before them is included. So coming from the left, negative infinity, never can use the infinities, all the way up until negative 2. Can't use that. Now that's just the first segment, so I need to include my union symbol. Now I have the second segment. That's everything from negative 2 until 2. Don't use them. And then now I have to use the last segment, everything from 2 until infinity. Okay, hopefully that makes sense on how interval notation works. Like I said, if you really want to write it using set notation, I guess that's fine. I would prefer that you didn't. I think interval notation is the best way to go. And I put some down here to practice. I don't have the answers for those. If you want to ask me in class, I'll be happy to walk through those with you. So now let's bring this all back to what our overall goal was today, the big idea. I mean, this was one thing, evaluating piecewise functions, but this is the much more far-reaching topic, which is finding domain and range. Just domain today. Find the domain of the given function. So remember, to find the domain, we look for problems. So I look at my function, and I look to see if there's an x on the bottom, which means in the denominator, and then to see if there's an x underneath the square root. So do we have an x on the bottom? No, we don't. Do we have an x underneath the square root? There isn't even a square root, so no, we don't have that problem either. So this doesn't have any problems, and when we don't have a problem, life is really easy. We can just go ahead and say that our domain, we use capital D to represent domain. Capital D, if there are no problems, that means every single number works. So in interval notation, every single number is going from negative infinity until positive infinity. Okay, let's get at the more interesting ones, the ones that do have problems. So part B, do we have an x on the bottom? Yes. Yes. So what we have to think about here is we have to look at this and say, all right, so what can't, now this doesn't mean x can't be 0. Divide by 0 is the error. But if I put 0 in for x, 3 times 0 is 0, subtract 2 is negative 2. That's not an error. That would be a negative 2 on the bottom. That's okay. What I want to do is I want to figure out where the denominator ends up equaling 0. So I'm going to take 3x subtract 2, and I'm going to say it cannot be 0. I've taken this idea of this, and I created the scenario that would check to find out when the problem would occur. So now if I bump over the 2 and I divide by 3, I would find that x cannot be 2/3. That makes sense. If I put 2/3 in here, 3 times 2/3 is 2. 2 take away 2 is 0. So 2/3 creates a 0 on the bottom, so 2/3 is the bad number. 2/3 is the only number that we can't have. So if I go to my number line now, the only point I care about is 2/3. I can't use 2/3, but I can use everything after it, and I can use everything before it. So this ties into the interval notation stuff that we just did on the back. So what would our domain be? Which x's can we use? So starting from the left, negative infinity, can never use it. Up until 2/3, can't use it. Union with 2/3 until infinity. So if you're looking at this, I mean, this segment, this section corresponds to that part of our domain. This section corresponds to that part of our interval notation. So let's go back up here and add a little bit to this. When there's an x on the bottom, that basically is saying that we cannot be equal to 0. So you take whatever's on the bottom and you say it can't be equal to 0, you solve it, and that'll find the problem for us. All right, so let's look at our other scenario, our other problem. So I look at this function. Are there any problems? Is there an x on the bottom? No. Is there an x under a square root? Yes. That means that for some x values, it's possible. It's possible. It doesn't always happen. Like, for instance, well, I'm not even going to worry about that. There's some x values that will cause this number to be negative. So let's just take something simply like 100. If I put x as 100, 3 times 100 is 300. 4 subtract 300, that's a negative number. So what we want to do is we want to eliminate all those problems that are bad. So this stuff underneath the square root, it can't be negative. Well, if you can't be negative, what's the exact opposite of negative? Now, a lot of people want to say positive. That's not true. The opposite of negative is non-negative. Because if you say just positives, what number are you leaving out? If I take all the negative numbers and I eliminate those, what numbers are left behind? All the positives, I agree, but also 0. So what we want to say is we want to say that whenever we have an x underneath the square root, we need to make this stuff greater than or equal to 0. Whatever's underneath the root must be positive, greater than 0, or it must be equal to 0, because you can square root 0. Square rooting 0, that's fine. Square root of 0 is 0. So I've got stuff underneath the square root, so I'm going to take that stuff, and I'm going to say it must be positive, or it must be 0. I'm going to solve this. Now, don't forget, I picked this one on purpose, so you could move either one of these, but I'm going to move the 4, because I want to talk about dividing by a negative. So I subtracted by 4. Now I'm going to divide by -3 and go back to your middle school days. When you divide an inequality by a negative, that inequality gets switched around. So this becomes a less than, and then the negatives are going to go away because they're both negative. But I still divided by a negative all along the way. So let's turn this into a little graph, and then we'll use the graph to help us figure out the interval notation. The only number I care about is 4/3. Okay, 4/3, can I use it or not use it? Yeah, I can use it because it's less than or equal to. So I'm going to fill in, and I'm going to go less than. That's everything on this side. Okay, so coming from the left, my domain then from the left, I'm going to start at negative infinity, which I can never include. I'm going to go until 4/3, and I want to include that 4/3. So really, there's only two things that you need to look for when you're looking for domain. You're looking for an x on the bottom, or you're looking for an x underneath the square root. When you have an x on the bottom, you take whatever's on the bottom and make it, it can't be 0. So we're going to say it's not 0. That will help us find the one number that's bad. And then our domain is all the numbers except that number. When you have an x underneath the root, all that stuff needs to be non-negative, which means we need to get rid of all the negatives. So we're going to take everything underneath the root. We're going to say it could be either positive or equal to 0, solve it, and then that would find all the numbers that are good. So I'm going to encourage you to pause here and try to do these last three. All right, let's see how you did. What would be a nice color here? I just did my greens. How about a yellow? All right, so do I have an x on the bottom? Yes. So I have an x on the bottom, which means this stuff on the bottom cannot be 0. Now I'm going to use my algebra skills. I'm going to bump over the 4. I'm going to divide by the 5, negative 5. So I get negative 4/5. So negative 4/5 is the one bad number. X cannot be, I forgot to do the not. X cannot be negative 4/5. That means it can be everything else. So my domain will be everything from negative infinity until negative 4/5. Can't be 4/5. Then union that with the other half, negative 4/5 until positive infinity. Next, look for problems. Do you have an x on the bottom? No. Do you have an x under a square root? Yes. So now we've got this stuff that's underneath the root has to be non-negative. So it has to be positive or it has to be 0. I'm going to do this one in one move. I'm going to subtract the 7 and divide by 2. I did not divide by a negative this time. I got a negative answer, but I didn't divide by a negative. Okay, so these are all the x's that start at negative 7/2 and go up from there. So my domain, if you wanted to draw a picture, draw a picture. I don't need to. I'm going to start at negative 7/2, sorry. And I want to use that, and I want to go all the way to infinity. And then the last one, do we have an x on the bottom? We do not. Do we have an x underneath the root? We do not. So life is good. That means our domain is negative infinity until infinity. Now, there's lots of notes that we get into that, you know, when you get to the homework, you can kind of do some, and then by the PQ, you get more practice on it, and you're pretty good. This is not one of those. This is one where I really encourage you to dig in, try to figure out the domain. Domain is not an easy topic, but once you get it, it's actually pretty simple. Good luck.